evening, students. Yesterday we were discussing about the addition of vectors. In the previous classes we have discussed the addition of vectors and as well the product of vectors. Now let us continue discussing the problems. Now see the first question there. Today's first question. A vector A bar has components A1, A2, A3. Vector A bar has components A1, A2, A3. In a right-handed rectangular Cartesian coordinate system OXYZ. The coordinate system is rotated about z-axis through an angle pi by 2. The components of A bar in the new system are. So understand that whenever you take the room in which you are sitting, this one has x-axis, this one has y-axis, this one has z-axis. Keeping z constant, if the axes are rotated, keeping z constant, if the axes are rotated, the rotation takes place in a plane. That is, in this case, xy plane only the rotation takes place. It is two-dimensional rotation. Two-dimensional rotation because z is kept constant. Now, you might have remembered in your first year of coordinate geometry, you have learned the change of axis. And the change of axis, you have learned the shifting of origin and the rotation of axis. In the rotation of axis, you might have remembered the original coordinates xy and the new coordinates xy. This is cos theta, this is minus sin theta, this is sin theta, this is cos theta. You might have remembered. Now in this case what happens, because z is kept constant, A3 remains as it is, and this is the original coordinate A1. This is the original coordinate A2. Now in this case theta 90 degrees. Here also theta 90 degrees. Now substituting this, we need the new coordinates. That is capital X is equal to x cos 90. That is A1 into 0 plus y sin 90 plus A2. So new coordinate, new x coordinate is A2 and new y coordinate, you can see A1 into cos 90, 0, this one. New y coordinate is this, A1 into minus sin 90, that is A1 into minus 1 plus A2 into cos 90, this is A2 into 0. So capital X comma capital Y becomes here A2 comma minus A1 and A3 remains as it is. This is the coordinates in the new system. So what happened here, if you consider this as x-axis, y-axis and z-axis, keeping z constant, if you rotate xy, if you rotate xy axis, that means in place of y-axis, x comes, in place the y-axis goes to negative x-axis. Y-axis goes to negative x-axis. Imagination is very important. And formula wise, it is only two-dimensional rotation, which you have already learnt in your first year of intermediate, that is rotation of axis. The same formula I used here, and the old coordinates are A1, A2. I have taken and I need the new coordinates and the angle of rotation, you can see the problem there. Angle of rotation is given to be pi by 2. So I replace theta with pi by 2 and I wrote the coordinates. It is A2 minus A1 and A3 remains as it is because the rotation has taken place with respect to z-axis. Go to the next problem now. The next problem in a triangle ABC, DE or points on BC. A triangle ABC, D, E or points on BC and AC. D is one point, E is another point on respectively such that BD is equal to twice 2DC. BD is equal to twice of 2DC. That is almost, if you double this, you will get this. That's what I have taken here. So BD is given to be twice 2DC. That's what the relation given there. You can go to the problem. AE is thrice EC. AE is thrice EC, almost 3 times of EC. if you take this as EC, this will give you, AE will give you thrice of EC. AE is thrice of EC. This is what the data given. Let P be the point of intersection of AD and BE. This is AD, this is BE. So now it is given to be P. Now what is to be find out by the point of intersection of AD and BE? Then BP by PE. BP by PE is needed. Come on, let us go through the problem again. In a triangle ABC, D and E are points on BC and AC respectively. BD is twice of DC, and AE is thrice of EC, and P is the point of intersection. P is the point of intersection of AD and BE. Now you have to find out BD, BP upon P. BP upon P is not known to us. It is to be find out. Let us suppose that it is lambda is to 1 minus lambda. That means I have taken this P divides B in the ratio lambda is to 1 minus lambda. What is it, sir? You can take it as lambda is to 1. Why should you take it as lambda is to 1 minus lambda? You will be understanding now. Now I'll take AP is to PD as mu is to mu minus 1. Now let us make A 0 bar and B bar and C bar. Let us write D now. Let us write D now from this one. This is OD minus OB. OD minus OB. That is OD minus OB means here O is taken to be A. So OD minus OB. What is OB? B bar. Twice of OD minus OC or OD minus OC. So this is OD, nothing but AD minus OC. What is OC? C bar. So from this one you can understand OD bar is nothing but 2C bar minus B bar. OD bar you have got it to be 2C bar minus B bar. This is 2C bar brought the side. This is minus B bar. So you have got OD bar now. Similarly, let us write D now, which you have got it to be 2C bar minus B bar. Let us write E now from this one. AE is nothing but AE. That is OE. AE is nothing but OE here. So OE bar is nothing but 3 into OC minus OE. What is OE here? OE is to be find out. OE plus 3 OE, 4 OE is equal to 3 OC. What is OC here? C. So what is OE bar here? 3 by 4 C bar. So you have got this as 2C minus B and you have got this as 3/4 of C bar. It is common sense that it is 3 times of EC, 3 times of EC. If you made it into 4 parts, 3 parts of AC, 3 parts of AC is nothing but AE. That's what we have written. So because it is 3 parts of 4 parts. So 3 by 4 C bar. You have got all the coordinates now. Now let me write P here. What is P? From this one. Lambda into 3 by 4 C bar. Lambda into 3 by 4 C bar plus 1 minus lambda into B bar. What is it I am doing? I'm applying the section formula. Mx2 plus nx1 upon m plus n. Because m plus n now you will understand what happens to m plus n here. 1 plus 1 minus lambda. Lambda getting cancelled and you will get 1. So you need not have to write the denominator in this case. That's what the advantage by taking ratio as lambda is to 1 minus lambda. So I have got P now on BE. Similarly, I will find out P on AD now. AD. See mu into this one. 2C minus B plus mu minus 1 into 0 bar. Need not have to written. Divided by mu plus 1 minus mu, please. This is 1 minus mu. This is 1 minus mu. Mu plus 1 minus mu getting cancelled. 1 only remains. Now comparing the like coefficients. Comparing C bar coefficient is 3/4 of lambda this side C bar is 2 mu, and this side B bar coefficient is 1 minus lambda, and this side it is minus mu. You have to solve this to get the value of lambda. If you get the value of lambda, if you substitute this, you will get the ratio. That's what the elegance of this problem is. That taking the ratio as lambda is to 1 minus lambda will make the problem easy for you. Otherwise, it will be lengthy, more lengthy. So, whenever you have to consider the ratio in this type of problems, take the ratio as lambda is to 1 minus lambda instead of taking it as lambda is to 1. If you take it as lambda is to 1, lambda you'll get directly, but here after getting the value of lambda in this case, now you have to substitute here. Lambda is to 1 minus lambda will be the required ratio, thereby you'll be getting BP by PA. That's what we require there. So this is the technique I want to discuss here in this problem is take the ratio as lambda is to 1 minus lambda, mu is to 1 minus mu. That will make the problem easy for you to solve. Okay, let's go to the next one. Now next one is a vector has components 2p and 1. A vector has components 2p and 1 with respect to a rectangular Cartesian coordinate system. This system is rotated through a certain angle about the horizon in the counterclockwise sense. If with respect to the new system, A bar has components p plus 1 and 1. P plus 1 and 1. A rectangular coordinate system is there. And A bar has components. I will write it as A bar is equal to 2p I bar plus 1 into j bar. And this system is rotated through a certain angle about the horizon in the counterclockwise direction. That is the horizon. This is x-axis, y-axis, z-axis. This is rotated through some angle. Rotated through some angle. So whatever the rotation is taken, the very important part, what you have to remember, in the shifting of horizon, what are the quantities, what are the parameters that does not change? In shifting of horizon, slope of the straight line remains the same. And always the area, distances, volumes, all these are constant. That is why even if you shift the horizon without rotation, all this remains the same. What are they? Slope of the straight line and the distance and the areas, and all these will remain the same in the shifting of horizon. And if you rotate the axis, what is that? Remains the constant. If you rotate the axis, remember, this is original coordinate system. This is after rotation, new coordinate system. New coordinate system. This is theta, this is theta. What is that does not change? If you take a straight line like this, and if you take its distance from the horizon is OP. If you take the straight line after the rotation, this much of length here, this much of length will be there, and it is this much of length, and you have to take that much of length here. So after rotation, the line will go like this. So this distance and this distance always remains the same. Remember a very important point here. Whenever the axes are rotated through some angle, the perpendicular distance from the horizon to a straight line. In the original system, the perpendicular distance from the horizon to the straight line in the new system always remains a constant. That means both are equal. So after the rotation, let us suppose here A bar dash is this one. So what happens here? When this rectangular coordinate system is rotated through some angle, its distance from the horizon and its distance from the horizon remains the same. So modulus of A bar is equal to modulus of A bar dash. What does it mean? Because the horizon means 0, 0, 0, the distance, because it is 0, you have to write the position vector. Like if I take this as A, this as B, and O as horizon, then AO is nothing but OO minus A. But that means it remains the same. Understand that. So because it is horizon, you can take like this. Now it is squaring on both sides. Mod a bar square is equal to mod a bar dash square. What is its modulus? 4p square plus 1. And what is its modulus? I'll write it in this way for your better understanding. P1 plus 1, p plus 1 into I bar plus j bar. What is the distance? What is the modulus here? P plus 1 whole square plus 1. 1 getting cancelled. It is 4p square is equal to p square plus 2p plus 1. And it is nothing but 3p square minus 2p minus 1 equal to 0. If you take the factors, 3p square minus 3p, 3p square minus 3p, take p common, 3p square minus 3p, take 3p common, and within the brackets you will get p minus 1, and it is p plus 1. These are the factors for this one, 3p square minus 2p minus 1. So what should be the value of p in this case? P is minus 1 by 3 comma 1. P is minus 1 by 3 comma 1. It is option number 3. So what is the property? Let us at first let us revise that property. If the axes are rotated through some angle, what is that quantity remains the same? That is, if you rotate the axis through some angle, the perpendicular distance from the horizon to the straight line always remains the constant. That means the perpendicular distance from the horizon to a straight line in the original system is equal to perpendicular distance from the horizon to the straight line in the new system. That's what I have applied here, and I have got p value as minus 1 by 3, 1. Let's go to the next problem. The next one is, we have already discussed this in the previous class. This one. Next problem, please. And product of vectors, it's very well known to you. Among the product of vectors at base, let us take this mod a bar, mod b bar into cos of angle between a bar, b bar, which is said to be scalar product. And a bar cross b bar, it's very well known to you, mod a bar, mod b bar into sine of a bar, comma b bar into some n cap, where n cap is equal to a bar cross b bar upon modulus of a bar cross b bar. What do you understand by this? The result is a scalar, and hence direction is not needed. The result is a vector, the direction is needed. So in this case, it is commutative. A dot b is nothing but b dot a. In this case, a cross b is not equal to b cross a, but a cross b is equal to minus b cross a. Why should it be minus b cross a? I'll explain you now. So if you take a bar cross b bar, what is a bar cross b bar? Let me take this one a bar, this one b bar. A bar cross b bar is, if you find out a bar cross b bar direction will be like this. That means it is always perpendicular to a bar and b bar. Remember that. Whenever you find out the cross product of two vectors, a bar and b bar, the resultant will be perpendicular to the plane containing a bar and b bar. That's what the understanding you must have. So here the definition of right-handed system and left-handed system. Understand that clearly, please. Right-handed system, left-handed system means if two vectors are there, a bar and b bar, and if you see from this point, the direction from a to b is in the clockwise direction. The direction from a to b is in the clockwise direction. The resultant vector will go backside to the board. That means you can understand this more clearly if I explain you in this way. If you observe screwing and unscrewing, screwing means to fit the screw, unscrewing means to get it out. So when you unscrew, let us suppose these are a bar and b bar, you are unscrewing like this, unscrewing. Then what happens? This comes up. That means when you apply a bar and b bar in the right-handed system, the resultant vector will be above its plane, which is a bar cross b bar. And when you apply screwing will be done like this. Then the resultant vector will be below the plane, which is b bar cross a bar. But what makes the difference? A bar cross b bar, the vector comes up, that is, it is above the plane, and b bar cross a bar, the vector goes below the plane, and both have the same magnitude, but their directions are opposite. The directions are opposite. To show that the directions are opposite, we put a minus here. So understand simple concept here to decide whether the system has right-handed system or left-handed system. Right-handed system, when you find out box ABC, for the right-handed system, you'll get always greater than 0. For the left-handed system, if you find out box ABC, it is less than 0. This is right-handed system. This is left-handed system. Not right-hand side, right-handed system, left-handed system. If you have three vectors in such a way that if the direction from A to B to C is in the clockwise direction, then the resultant vector will be opposite side of the plane, and if it is the direction is from the clockwise direction, then the resultant vector will be above the plane. So above the plane is taken to be positive and below the plane is taken to be negative. So whenever a question is given on right-handed system or left-handed system, find out the box ABC. And if box ABC is greater than 0, right-handed system. If box ABC is less than 0, the system is left-handed system. Okay, so this is what the vector product, and this is what the scalar product. You all know that. And coming to triple product, how triple products are defined, let me briefly explain you this. Triple products means if you take A bar, B bar, C bar, how the dot and cross can be distributed among them. Dot can be distributed like this, like this, like this, like this, like this, like this, in this way, in this way, and in this way. This is not defined. Why? This is a vector. This is a vector. This is a scalar. Vector dot scalar not defined. And this is a scalar. This is a vector. Scalar dot vector not defined. This is a scalar. This is a vector. Scalar cross vector not defined. It is a vector. It is a scalar. Cross product not defined, because the title of the topic is product of two vectors. Product of two vectors. So here it is not a vector. Here it is not a vector. It's a scalar. But here it is a vector. It is a vector, and dot product defined. It is a vector. It is a vector, and hence dot product defined. It is a vector. It is a vector defined. It is a vector. It is a vector defined. So if you see these two, the result is a vector, and hence it is said to be vector triple product. And if you see these two, the result is said to be scalar triple product. Understand this carefully. If the result is a scalar, then it is said to be scalar triple product. If the result is a vector, it is said to be vector triple product. This is briefly about this. Okay, now let us discuss more and more concepts while working out the problems itself. Now the first very basic questions I have taken in the next part of it. If theta is the angle between two vectors A bar and B bar, A bar dot B bar is less than 0, only if that is the dot product is taken to be less than 0. And if you expand this mod A bar mod B bar into cos of A bar comma B bar less than 0, this is anyway positive because they are the lengths. They are the lengths. They're always positive, and which should be negative here. Cos of A bar comma B bar is less than 0. That means it is less than 0 only when the angle lies between 90 and 180. Because in the second quadrant, cos is negative. So in the first quadrant, cos is positive, but it is given to be negative. So, and hence this A bar, B bar must lie between 90 and 180. Very simple problem. So option is 2. Go to the next question, please. A bar comma B bar is equal to 0 degrees or 180 degrees, then A bar comma B bar or what? The angle between the two vectors is 0 degrees. Let us take, this is A bar, this is B bar. Angle between them is 0. Either they must be parallel or coincident if it is 0. And if it is like this, it is 90. If it is like this, it is acute, it is 90. And if it is like this, it is obtuse. If it is like this, it is 180. Understand that. It is 180. So either 0 or 180, then what happens? If it is 0, parallel. If it is 180, it may be like this or it may be like this. That means they must be parallel or coincident. So what is option there? They are parallel. Very simple. You all know that. Let's go to the next question. A bar comma B bar is equal to 30 degrees and A bar comma minus B bar is equal to A bar B bar. The angle between A bar B bar is given to be how much? 30 degrees. And if it is A bar, this is nothing but minus A bar, please. Exactly, this is in this direction A bar. And in this direction it is minus A bar. So angle between minus A bar B bar is needed, or A bar minus B bar is needed. Whatever it is, not a problem. Whatever it is, not a problem. Minus B bar is taken this side. This is minus B bar. You want the angle between this or you want the angle between this, then what happens? It is 180 minus 30. It should be 150 degrees, please. So the option is, it is very clear, it is 150 degrees. You understand this? This is acute angle. Other one will be obviously obtuse angle. To show that, we have taken this one A bar minus B bar or minus A bar B bar. Both are 150 degrees only. Next one, A bar dot B bar is equal to mod A bar mod B bar. Then the vectors A bar and B bar are like vectors, equal vectors, perpendicular vectors, unlike vectors. A bar dot B bar is mod A bar into mod B bar. What does it mean? A bar dot B bar is nothing but mod A bar into mod B bar into cos of angle between A bar comma B bar. This is only to exist. That's what it is given there. A bar dot B bar is equal to mod A bar into mod B bar is given. You can go through the slide, you can go through the problem there, and it should be 0. Sorry, it should be 1. This is to become, in the question given, this is to become cos of A bar comma B bar must be 1. When it becomes 1, A bar comma B bar is 0 degrees or 180 degrees. This becomes 1. Cos 0 is 1. Either it should be 0 degrees or 180 degrees. If it is 180 degrees, what happens? This becomes minus 1. Then you must have minus here. But minus is very much given there. So you have to take this as minus, and hence 0 degrees is not applicable. Only 180 degrees is applicable. Please go to that. A bar dot B bar is equal to minus mod A bar into mod B bar into cos of A bar comma B bar. And hence in this case, what happens? This minus 2, you to get minus there, it must be 180 degrees. So if you see the options, like vectors, equal vectors, perpendicular vectors, unlike vectors, the angle will be 180 degrees. Okay, go to the next one. The sum, if the sum of two unit vectors, if the sum of two unit vectors, A cap plus B cap, unit vectors means I have taken them to be unit cap. If the sum of two unit vectors is a unit vector means its modulus is given to be 1 here. Then the magnitude of their difference, this is modulus of A cap minus B cap, is to be found out. Very simple question only, but getting the idea is important here. Like what? Using the given data, you can write modulus of A cap plus B cap whole square plus modulus of A cap minus B cap whole square is equal to twice of A cap square plus B cap square. What is that? Simple. A plus B whole square plus A minus B whole square is twice of A square plus B square. So this is nothing but given to be 1 plus modulus of A cap minus B cap whole square is equal to twice of 1 plus 1. It is 4, and it is modulus of A cap minus B cap whole square is equal to 4 minus 1, 3. And if you want the magnitude of it, it is nothing but modulus of A cap minus B cap is nothing but root 3, please. The answer is root 3. Understand, whenever you want to find out the modulus of any vector, you cannot, of course, you cannot directly split it. That is why whenever you want to find out the modulus of any vector, you have to take always its square. Why? Because I'll discuss this very important point here. Because a bar square is nothing but mod a bar square. Why is it so? A bar square is nothing but a bar dot a bar. A bar dot a bar, if you apply the dot product here, mod a bar into cos 0. Cos 0 is 1. So that is why whenever you want to find out the modulus of any vector, consider its square and remove the modulus and expand it. Remember, in the product of vectors, particularly in the scalar product, what all the algebraic formula you have, they can be directly taken. What all the algebraic formula means? A plus b whole square can be directly taken. A minus b whole square can be directly taken. A plus b whole square plus a minus b whole square can be directly taken. Like that, what I'm saying, all the algebraic formula can be taken directly in case of scalar product. So remember, whenever you want to find out the modulus of any vector, you cannot find it directly unless you get its square. Get its square and remove the modulus and expand it, and like this you will get the answer. So that's how you can find out the modulus of any given vector. Let's go to the next problem. A bar given, B bar given, and C bar given, and A bar plus lambda B bar is perpendicular to C bar. Most generally, the application of dot product, generally the perpendicularity is mostly used, because if the two vectors are perpendicular, then their dot product is always 0. That is why, because the dot product of two vectors is always 0, this property is mostly used in the problems related to scalar product. So in the problem, please go to that problem. A bar I plus 2j plus 3k. This is I plus 2j plus 3k. Lambda into, what is B bar there? Minus I plus 2j plus k. Minus I plus 2j plus k. Dot of, what is C bar given there? 3i plus j is equal to 0. So what do you understand by this? 1 minus lambda into 3. J bar coefficient is 1 here. It is 2 plus 2 lambda into 1. K bar is not there, so it can be neglected because you'll get into 0 is equal to 0. So it is minus 3 lambda plus 2 lambda minus lambda 3 plus 2 5. 5 minus lambda is equal to 0. Lambda is equal to 5. This is what you have to understand there. So simple thing, what you have to remember in the scalar product, if two vectors are perpendicular, then the dot product of these two vectors is 0. Remember that. Go to the next problem now. The next one, if Q be the angle between the vectors 3i minus 2j plus k and 2i plus 3j, then the value of Q is, Q means, you take it as always to find out the angle, it is cos Q, let me say, according to that, is A1A2 plus B1B2 plus C1C2 upon root over A1 square plus B1 square plus C1 square into A2 square plus B2 square plus C2 square. So apply the same formula there also, that is 3i minus 2j plus k. It is in three-dimensional. What the formula you know is cos theta, or here it is cos q, is a bar given to be that one 3i plus pj plus pk. 3i minus 2j, 16th problem please. 3i minus 2j plus k dot of 2i plus 3j divided by its modulus. This is nothing but modulus. Its modulus is 9 plus 4 plus 1, and it is 4 plus 9. So it is 6 minus 6, it is 0. When you get 0, Q is 90 degrees. So these two vectors are perpendicular to each other. It's clear, you need not have to apply this. At a glance, you can see this type of problems. Without putting your pen on the paper, you can say the answer. If you see the vectors carefully, 3i minus 2j plus k. Second one is 2i plus 3j. Then when you find the dot product there, 3 into 2, 6 minus 2 into 3, minus 6. 6 minus 6, 0. Dot product is becoming 0. Dot product becomes 0 when the angle between the vectors is 90 degrees. Simple. Okay, next question please. 17th question. If a bar is equal to 3i minus pj plus pk, b bar is equal to 5i plus 2j plus pk, and if the angle between a bar and b bar is obtuse, then the possible values of p lie in. What are the vectors? There are two vectors given. One is a bar, another one is b bar. When the angle between them is obtuse, a bar dot b bar should be less than 0. Why is it so? Dot product, if you see the definition, a bar dot b bar mod b bar into cos theta. So cos theta should lie in the second quadrant. That is, theta should lie in the second quadrant. Then only cos theta becomes negative. When cos theta becomes negative, obviously the dot product is less than 0. So I'll substitute the values of a bar and b bar and find out the dot product. If you write the dot product, it is 15. Is it 3i minus 5i, please? So minus 15 and minus pj plus 2j. So minus 2p and pk plus pk, that is p square, should be less than 0. Do you understand what I'm saying? If you want, I'll write the total step. If you are following the problem carefully, if you look at the problem, what the step I wrote, you will understand. But let me write that completely. 3i minus pj plus pk dot of b bar minus 5i plus 2j plus pk should be less than 0. Implies minus 15 minus 2p plus p square less than 0. What are the factors here? It is minus 15, so phi 3 is 15, so p square minus 5p, so take p common, p minus 5, and it is p plus 3 into p minus 5 less than 0. This is what you have got here. P plus 3 into p minus 5 less than 0. When it is less than 0, p belongs to minus 3 comma 5. So what should be the answer there? First option, you can see that clearly. When the angle is obtuse, the dot product will be less than 0. Apply that, simply get the answer. Next one, please. A is 2, 3, 4, B is 5, 4, 3. Then the length of the orthogonal projection of AB bar on the line whose direction cosines are 1, 0, 0 is. This is an important concept. Understand, whenever you take a vector AB and another vector CD, if you drop a perpendicular from A onto CD and from B onto CD, let us suppose this meets in A dash, let us suppose this meets in B dash. A dash B dash is said to be the orthogonal projection of AB on CD. This is always 90 degrees. I repeat, whenever you need the orthogonal projection, drop the perpendiculars from the extremities onto this vector, onto the required vector. Drop the perpendiculars from the extremities onto the required vector. So orthogonal projection of AB on CD is nothing but A dash B dash. So let us suppose this is A bar, this is B bar, this is B bar. Orthogonal projection of A bar on B bar. Orthogonal projection of A bar on B bar A bar on B bar. Always remember, when you take A bar on B bar, it starts with A bar and remaining all will be B bar only. If it is the reverse, that is B bar on A bar, starts with B bar, remaining all will be A bar only. The same is to be applied there also. A 2, 3, 4, B 5, 4, 3. Then the length of the orthogonal projection of AB on the line. What is A there? What is A 2, 3, 4? What is B there? 5, 4, 3. What is A bar in this case? OB minus OA. 5 minus 2, 3. 4 minus 3, 1. 3 minus 4, minus 1. This is A bar you have got. What is B bar given? It is clear. 1, 0, 0. These are the DCs. DCs generally should be represented without brackets like this. Without brackets like this. And now, if you apply the formula 3 into 1 plus 0 plus 0. A dot B upon mod B. Mod B is 1. So answer is 3. You can check it out. It is 3. So orthogonal projection of a vector on another vector, the formula A dot B upon mod B, it is the length of the orthogonal projection. Don't forget that. This is length of the orthogonal projection. Length. If you want the vectorial orthogonal projection, it should be a vector. Then it will be like this. A dot B into A bar upon A dot B into B bar upon mod B bar square. Remember this. This is a formula. If it is to be in the vectorial form, A dot B into B bar upon mod B bar square. And the result we have already seen for that problem. Okay. Now let's see the next one. Next one is mod A bar is equal to mod B bar, then A bar plus B bar dot of A bar minus B bar. Mod A bar is equal to mod B bar. This is a simple question, but why I have chosen this, you must understand this in this way. It is what I said in the dot product. You can comfortably apply all the algebraic formula like A plus B into A minus B is nothing but A bar square minus B bar square. What should be the next step? Next step should be like this: mod A bar square minus mod B bar square. Why should it be? Just now I explained you. A bar square is nothing but mod A bar square. With modulus or without modulus, if you have square, both are equal. That's what I want to say here. Mod A bar is equal to mod B bar, both are equal, and hence it becomes 0. So the point to be noted in this case is A bar square is equal to mod A bar square. So whenever you want to find out the modulus of a particular vector, remember, always consider it's a square and then expand it. Okay, this is a simple problem. Let's go to the next one. If the scalar product of the vector I plus j plus k with the unit vector parallel to the sum of the vectors 4i, sum of the vectors 2i plus 4j minus 5k plus xi plus 2j plus 3k. 2j plus 3k. This is sum. It should be 2 plus x into I plus 6j minus 2k. This is the sum. So what do you understand by the problem? If the scalar product of the vector I plus j plus k dot of with what? The unit vector parallel to the sum of the vectors. You want to make it a unit vector. 2 plus x into I plus 6j minus 2k divided by square root of, divide it with its modulus. 2 plus x whole square plus 36 plus 4. That means I have got the sum of the two vectors and I have made it a unit vector. And the unit vector dot product with a given vector I plus j plus k is equal to 1. that is given very much. So what is that you find here? If you find out the dot product, 2 plus x plus 6 minus 2 upon this is equal to 1, which is equal to square root of 2 plus x whole square plus 40. Simplify this. 2 to getting cancelled. X plus 6 whole square is equal to 2 plus x whole square plus 40. After this, you can solve the equation. Otherwise, verify the options. Whatever the options you have, you can verify the options. So this is x square getting cancelled on both sides. Now it is 12x plus 36 is equal to 4x plus 44. Now from this one, you can get the value of x. X is nothing but here 8, here it is 8x. So x is equal to 1. You can see the option there, x is equal to 1.